Hello students, good afternoon. Welcome back to class. Okay, as in the previous class, we started with the new lesson, magnetic effect of a electric current. Before going to that, I will take the revision on the lesson electricity. So, what are the concepts that comes under this electricity are the firstly, what is the electric current, then the followed by the what is the SI unit, and then comes the potential. So, how this electric potential formed and the potential difference, and then the relation between the electric current and the potential difference, that is nothing but the Ohm's law, and then some applications regarding the Ohm's law, and then comes the resistance and the resistivity. So what are the conditions that will make impact on the resistivity, means the factor affecting the resistivity, and then the resistors connected to electric circuits. So in that case, if we take the two or more resistors, if they are connected in series, what will be the output we will get? And the next one is a resistors connected in a parallel combination, and what will be the output? And the next one is a heating effect of a electric current, and lastly electric power, right? So all these concepts that you have studied in this electricity lesson. So the firstly, what is the electric current? So in this electric current, you are going to see these applications in a wide variety of the technologies, like you are going to use electricity in your schools, homes, and some industries, and almost all of the shops that there is no such a kind, there is no electricity. So in our day-to-day life, the main required condition is the electricity, and that is the electric current. So what is this electric current? This means, for example, I will give when there is a water flowing, means if we want a water, there must be flow of a water from one place to another place. Similarly, in the electric currents itself, the flow of charges will be takes place. That will form the electric current. It means what? The flowing of charges that will produce the electric current. So, flowing of charges that will produce the electric current. For example, when the electric charges passes to a conductor, that will causes the electricity. So, what are the conductors? I hope you all know that. The conductors are the materials which will allow the electricity and heat passes through them easily. Such type of materials are called as the conductors. I hope you have learned this in your 7th class. In the heat lesson, that they will come across the conductors. So conductors means the substance of the materials which allow the heat and electricity to pass through them easily. Such kinds are called as the conductors. So the example for conductors are metals. So almost all the metals that comes under the conductors. And the next one we have is the insulators. So these insulators are opposite of conductors. What is it means? They will not allow the heat and electricity to pass through them easily. Means they will not allow the electricity to pass through them. For example, wood. It is the best example. This wood will not allow the electricity to pass through them easily. So you can observe that in making of electrical wires, they supposed to use the metals like copper, and some in case of aluminium, iron. So such a kind of metals are used, but not they will use the what? Wood. So the example for insulators are wood, and the conductors are metals. So when the electric charges flows through these conductors, there is a formation of a electric current, right? So you are observing the electric currents in your home appliances. So how these electric charges, what are the content present in the electric charges? In these charges, there is a presence of electrons. So that will allow the electricity to pass through them easily. So this is about the electric current. So then what is the electrical circuit? So the next is the electric circuit. So what is that electrical circuit? So electrical circuit means a continuous and a closed path of an electric current. Means it must be consist of conductors and and it is connected to a continuous path and it must be a closed path. Okay, so such a circuits we call it such a currents which produces in the circuit, that we say represent as an electrical circuit. For example, I am taken here a bulb. Okay, so I am taken here the bulb, and when this bulb is connected to a positive charge and then it is connected to a negative charge and it will be formed with some key and it is connected to another end of the bulb. So this overall, for your example, I take this when this is a closed path, right? So it is not opened at all in any condition. So the positive charge is connected to a bulb and another end of the bulb connected to the key, and the key is then connected to the same cell. So here this is a complete and a closed path, and here it is there is a continuation is there in between all these materials. So this is, we call it as a electrical circuit. So the thing is a continuous and a closed path of an electric current, that we refer it as a electrical circuit. So in this electrical circuit we are going to use the cell, then the bulb, and then the key. Here it is not a closed, here it is a closed key. Okay, key, and it is a bulb, and it is a positive and a negative charges, and it means if this is a single, it is a cell, and if it is two or more, then we say it as a battery. Okay, so battery comes, and then you have a resistors. Okay, so this is a resistor, and then you have a variable resistance, that we in generally shown it as a like this way, and it is a this. So it is, we call it as a variable resistance, or in case we also refer it as a rheostat. So these are the some the materials we are going to use in case of a electric current. So how from which direction does the electricity or the electric current will be passes? Okay, I will take another example. For this, when there is a water in a horizontal pipe, there is no connection, but when you are allowed to pass through the horizontal pipe, is there any water flown in the horizontal pipe? Certainly not. If one end is connected to a higher point and another is connected to a lower point, there must be a flow of water from a higher region to a lower region. In the same way, this electric current will also passes from a higher region to a lower region. Okay, so in this positive side, what are the present? Positive charges are present. So the current will be passes from this direction, means positive to a negative direction. So here positive charges are present. In the negative side, there will be negative charges are present. So negative charges means negative electrons. So the electric current passes from a positive end to a negative terminal. Okay, so this is about the electrical circuit and the electrical resistance. Then comes the electrical potential. So what is this potential? And we have another word called a potential difference. So what is this potential difference? Potential difference means there must be a difference in the potential of the circuit, that we generally refer it as a potential difference. So this potential difference formed due to the electrical potential difference, means variation of a electrical pressure in the electrical circuit, that will produces the potential difference in the cell. Here we consider the cell because there must be a flow of electric charges or the electrical pressure between any 2 points. That's why we consider the potential difference. So how we define the potential difference? The potential difference between any 2 points in the cell is formed by the amount of work done in a unit charge, that will produces the potential difference. Okay, so this potential difference is denoted as a V, and this is formed when there is a work is done between any two terminals of the cell and having the charge Q. So there is a flow of charges in the electrical circuit, that will produce the potential difference. So the SI unit of a potential difference, we taken it as a voltmeter. So this voltmeter is volt is a unit, SI unit for this potential difference named after the scientist Alexander Volt, who invented this potential difference. That's why it has a volts. So the device which measures the potential difference, that is we call it as a voltmeter. So it is same as that of the potential difference. There is a electrical current formula. So what is that? What is the definition of electric current? Means there is a flow of charges, right? This is a charge. So there is a flow of charges in any cross-sectional area in a unit time. So that we call it as a electrical current. That is, I is a electric current that is equal to charge flown through any cross-sectional area in unit time. So that is we call it as a electrical current. So the SI unit of a electrical current is amperes, which we denoted it as a capital A. There are certain other units are also there. There is a micrometer is there. So it is 10⁻⁻⁶. Okay. Then milliammeter is there. Okay. So that millimeter is 10⁻⁻3. And amperes, and then we have the device ammeter, which will measures the what? Electric current. That device is called it as a ammeter. Okay. So there is another type of electrical device is there which measures the electric current with the flow of its direction. So such a kind of a device is that we refer to as a galvanometer. Okay. Please be remember, so the difference between the ammeter and the galvanometer is, this ammeter will shows the electric current, how much electric current is produces or formed in the electrical circuit. So this galvanometer will shows that how much amount of electrical current is produced and in each direction thus this electricity is passing, that will be measured by this galvanometer. So this is all about the potential difference and the electric current. So observing this, there must be a link between these two. What is potential difference and the current? So what is this potential difference and the I? So this is nothing but the Ohm's law. What is that? So the Ohm's law states that the electrical potential difference in an electrical circuit is directly proportional to electric current produced in that circuit. That is V proportional to I. So when to remove this proportionality sign, we are adding the proportionality constant. What is that constant? That is nothing but the R, which is a resistor or the resistance. Okay, so this is what the formula for a Ohm's law, V equals to IR. So by observing this formula, you can easily write the statement of the Ohm's law. What is that? The potential difference in the electrical circuit is directly proportional to the electrical current produced in that circuit. To remove this to remove this proportionality constant, proportionality sign, we are adding the proportionality constant, that is R, that is resistor here. Okay, so this is about a Ohm's law. Then you have the next is the resistivity. So what is called a resistivity? So the resistors, before going to resistivity, the resistor is a property of a conductor which resists the flow of electric charges in the electrical circuit. Means it resists the flow of charges in the electrical circuit. That we refer it as a resistors. So this is the SI unit of a resistor is a ohm. Okay, so that is we represented as like this, ohm. Okay, so this resistor that depends upon some factors. Means when there is a resistance in the electrical circuit, it must depend upon the certain conditions like length of the wire and some cross-sectional area, and then what is some other conditions that may be impact on this resistor. So what are those? Means there are some factors which affects on the resistor in the electrical circuit. So they are nothing but the resistance is directly proportional to its length. It means what? if the length of the conductor used is more, then the resistance produced in the electric circuit will also more here. So from this we say that if the length is less, then the resistance produced in the electric circuit will be less here. And this resistance is also inversely proportional to its cross-sectional area. Okay, so if the area covered means how much amount of area that we are considered in the electrical circuit is less, then the resistance is more. If the area is more, then the resistance is less. So from this we say that this resistance is inversely proportional to area. So we write by taking this as a R is proportional to length by A. So this is what we say that resistors that makes the impacts or these are the factors affecting the resistance in the electrical circuit. So this is what resistance and the materials which are affecting the resistance. So to remove this proportionality sign, we are going to add the proportionality constant. That is what here it is a rho. So this rho is, we call it as a electrical resistivity. So this electrical resistivity is nothing but the property of the material in the electrical circuit. Okay, so this electrical circuit must have a certain unit. How we can call it as? So R is equals to rho into L. Length means we are measured in terms of a meter, right? And this is a cross section area in case of a meter square. So here when this will be cancels means this meter and this cancels, left with a 1 meter. Okay, so R is measured and rho into 1 by m. So why I am taken here? We have to calculate the SI unit of this rho. For that we taken the rho as, okay, I will write here. Rho equals to, how we can write? R into area divided by L. Okay, so rho equals to, R is measured in terms of, means resistor measured in terms of ohm, and length is measured in meters. And area is measured in terms of a meter square and length is in a meters. So this will cancels and left with the ohm meter. So this is the SI unit of a electrical resistivity. Okay, so this resistivity is nothing but what? It is the property of a material in the electrical circuit. So the next coming is we are going to apply the electrical resistors in our electrical circuits. So in such way, okay, by taking the 2 or 3 resistors in the electrical circuit and they are connected in series in the electrical circuit. So how the flow of electric charges takes place, what may be the difference in the electrical circuit. Okay. So students, here I am showing that resistors are connected in series to a electrical circuit. Okay, if there is a end-to-end connection is there in between the resistors, then it is a series combination. Okay, in parallel combination what happens? The same ends are connected to a same point and another same ends are connected to a other different point. So that is a parallel combination. Before that, the resistivity of the materials for conductors, insulators and alloys are different. So this resistivity is low or the less for the metals or the conductors and the alloys, and it is more for the insulators. So from this we say that we can say the metals like copper or aluminium have the less resistivity, and the wood and some plastic or other insulators have the more resistivity in their in the electrical circuit. So in your textbooks they have given you examples of the resistivity of different materials. Okay, so in this resistors, when connected in a series in electrical circuit, what happens? The same electrical current that will be passes through the electrical circuit here. So here from this, when we on the key, there is a flow of charges starts here. From the positive N2 it will start with the emitter and it reaches to a resistor of a X point. Okay, here what happens, the same current in this electrical circuit is passes here, but the potential difference is divides here, means the potential difference potential difference from one point to another point will be varies here, but current, what is that, I1, I2 and I3 in all these cases will be same here, but the potential difference is what happens, it will be divides and it is equal to the sum of potential difference in the electrical circuit. So that we written as a V1 plus V2 plus V3, that is equal to capital V. So this is what a total potential difference. So we can write the Ohm's law. Using the Ohm's law we can calculate what is the resistance produced in the electrical circuit. So we take this as a V equals to IR. We know that this is a Ohm's law. So we are putting the V1 and the current here. So V1 is taken as a V is taken as a V1 and I will be remains as it is. Why? Same electric current will be passed here. So the resistance is what here? R1. So for a V1 potential difference, the resistor is R1. Then for a V2 it is a R2, and then for V3 it is a I into R3. So this is what the, from Ohm's law we write the potential difference. So we will equate these all equations with the Ohm's law, that is V equals to, I means what? We are adding these equations from this here. Okay, V equals to V1 means I into R1 plus I into R2 plus I into R3. Right. So when we take the I common, we get R1 plus R2 plus R3. Right. So when we take a V by I, that is a R. Okay. I will write here R equals to R1 plus R2 plus R3. So in this case what happens? The total resistance of the electrical circuit is equal to the sum of the resistance produced by the resistor. Okay. So this is what the total resistance that is formed or the produced in this electrical circuit. Okay. Is that clear? I will repeat once again. In the series combination, what happens? The electrical current, whatever that passes, it is same on all the parts of the electrical circuit, and the potential difference will be changes here. So that potential difference will be V1, V2 and a V3 here. Okay. So that potential difference is taken as a V1, V2 and V3. So from applying this in the Ohm's law, we will get the resistance, that is R equals to R1 plus R2 plus R3. So in the parallel combination what happens? The current will be divided here, but the potential difference remains the same. So in that case there is a change of a formula, means the resistance produced in the electrical circuit will be what happens? It will be 1 by the resistors, means 1 divided by R1 and 1 divided by R2. So this kind of a resistance is produced in the electrical circuit. So in case of a parallel combination, what happens? Resistors are connected to a same end, means this is a left side, this is a left side and this is a left side of the resistor R1, R2 and R3, and right side are connected to a same point, and that will be connected to another terminal of the electrical circuit. Okay, so this is the parallel combination here. So in this case, when the key is on, okay, this is the key and this is a battery. Sorry, I am writing now. You can observe here. This is a, when key is on, the current will passes. Okay. So this is what the resistors are connected in parallel. So in this case, what happens? As I already told, the current will be divided, that is I1, I2 and I3, and it will be same potential difference across this electrical circuit. That I will tell you in the next class. Okay. Thank you.